Thanks very much. Thanks, guys, for having me. We should switch over to the presentation now. Since I have the floor, I can say that ThoughtWorks is indeed hiring, so if you want to come to work for us, we do fly around in airplanes a lot, but we have a lot of local work right now, so you might want to roll the dice and see how local you can stay and still work for ThoughtWorks. There's a lot of interesting stuff going on. But tonight, what I'm here to talk about is hypothesis and data-driven development using feature toggles. Now, this talk started out as just hypothesis data-driven development. I ended up adding feature toggles because that's the way you end up implementing a bunch of these ideas. And this is in the category of sort of 21st century engineering techniques. So what I'm going to talk about during this talk is a bunch of things about ideation on software projects. A bunch of stuff about engineering practices that come from the continuous delivery world, but all toward this goal of how can we support this idea of hypothesis or data-driven development, and a little bit about evolutionary architectures and how to implement this stuff. But along the way, I'm going to give you 3 case studies of where this is applicable, and here's the first one. And this is a story from the magnificent podcast Radiolab. So if you're not a listener of Radiolab, you should be. It's not a technology podcast. I guess it's science journalism maybe, but it is one of the best podcasts on earth. Every episode is just a little chunk of literature. If you want to completely blow your mind, download the CRISPR episode of Radiolab and it'll keep you up at night. There's a CRISPR Revisited too. But the one I'm talking about here, it's called The Trust Engineers. And this is told as an interview between this journalist and these Facebook engineers who described a problem they encountered. Between Christmas Day of 2013 and New Year's Day of 2014, Facebook users uploaded more photos to Facebook than all of Flickr at that time, which is a large number of photos. But more troubling was, more than 1 million of those photos were flagged as inappropriate. Now, Facebook has a policy that says if anyone flags a photo as inappropriate, we will go and try to objectively assess, is this inappropriate or not? And if it is, we'll take it off of our site. And more than 1 million photos were flagged as inappropriate, and this has now become a big business problem for them because they don't have enough people to sort through 1 million photos, and if you start extrapolating into the future, this is an existential business problem for Facebook. And even more troubling, when they started looking at some of the 1 million photos, many of them were not objectively offensive at all. They were things like a kitten, or an acoustic guitar, or people standing in front of a bonfire on the beach. And they were like, why are people flagging these photos as offensive? Fortunately, they have 21st century DevOps at Facebook, along with the ability to run experiments on their users. The interviewer asked these engineers, as a Facebook user, what are the chances I've been involved in one of your experiments? And he said, 100%. You're probably in 3 experiments right now. Because they constantly experiment with their users to see what their users really want or what they're really doing to learn more things about them. And they use this superpower that they have to put out not just a checkbox that says offensive, but that now is a button that leads you to another page where they start asking questions to figure out why you said it was offensive. And it turns out things like the kitten and the guitar were lost in a divorce, and I don't want to be reminded of that, so that offends me. Okay, there's one category of things. And they found out all sorts of subtle things about human nature. So for example, no one likes to admit that they look bad in a photograph, but they will freely admit that a photographer did a terrible job photographing them. That's a really subtle distinction, but you make that change on the Facebook questionnaire and vast numbers of people go one way or the other. And so they use this ability to do A/B comparisons and learn stuff from their audience to refine this dialogue so that now they have a much better automated system of flagging truly offensive photos, and now they can actually handle the manual part in a reasonable way. This is an example of needing to learn something about what your users are doing. Too often, even on hardcore agile projects, the way that you come up with new stuff is that smart people go into a windowless meeting room somewhere and write things on index cards or put things on whiteboards and then come up and you implement that stuff. How is that different from big design up front? because you're thinking about a bunch of stuff and then you're implementing it. Of course, the feedback loop is a lot shorter, but what if you didn't do that, but instead started learning things about what your users wanted rather than just guessing what they want? So metaphorically, what you've been doing is cooking a buffet. You go in the back, you come up with recipes, and you cook all these dishes to completion and lay them out for your users. And some of the dishes they really like, and some of your dishes they treat like vegetables. The question is, how can you get them to like all of them? So what we're going to do is create a tasting menu and say, well, if you like this, we'll cook more in this category. If you don't, then we'll stop doing that. So that's really this idea of hypothesis-driven development. So let's talk about how to implement that. In the early days of Agile software development, we got really good at all this early stuff of doing analysis and design and development and iterations, et cetera. But then in a lot of organizations, code went to a very unagile place, to integration and then operations where it spent most of its lifetime. This is what was known as the last mile. And for a long time, all of us developers who were sitting up on the front end of development over here complained that it seemed like the last mile was always broken and why don't they ever fix that? But then at some point we realized, because of continuous delivery, that if QA finds a bug, where do you fix that? Well, back up in development. What if operations finds a bug as they're trying to put your code into production? Where do you fix that? Back over here in development. So that's a feedback loop. And what we did, we killed the waterfall inside the development team, but then stretched that out across the silos in the organization. And one of the things we learned from continuous delivery is you got to do all those things all the time. You got to do machine provisioning and QA and all those things in an automated manner. And in fact, that's what most people go after continuous delivery for, because continuous delivery is really just a kind of a neat marketing term for efficient engineering practices for software projects. But what a lot of people don't realize once they've implemented a handful of these continuous delivery features is they've accidentally also given themselves a superpower. And that's really what this talk is about, is that superpower. You know, the driving force between any agile methodology, the reason they all work is because of feedback loops. And not just feedback loops, but nested feedback loops. Unit testing, continuous integration, iterations, all those things are examples of nested feedback loops. But there's one feedback loop that has always eluded us, which is the one that includes our user. Hypothesis-driven development allows us to incorporate our user into our feedback loop as well and learn a bunch of interesting stuff from them. So let's talk about how to implement this. And I'll talk about it in three pieces. The engineering side of how you implement this in code with feature toggles. How do you change ideation, both from a hypothesis and a data-driven standpoint, and a little bit about how do you operationalize this stuff. What does the operational side, the DevOps side of hypothesis-driven development look like? But I'm going to start in the middle here and talk about the engineering practices around feature toggles. And I'm going to start this discussion with a discussion about continuous integration, because this is going to lead us to feature toggles. So let's talk about continuous integration for a second. Back in the 70s and 80s, if you looked at software projects, there was always a phase in that software project called the integration phase. And it was considered a best practice at that time for developers to work in isolation for weeks or months at a time. At the very end of the project, integrate all that code together in this big integration phase to create a release for your software. And not surprisingly, this is a pretty horrible experience on a lot of projects. And in fact, there's a pretty strong correlation here between the size of the project and the horror that is the integration phase on that project, because the more you got to get to try to work together. It wasn't like they chose this because it was the best way to do stuff. It was much more like, well, let's just get the stuff done we can, and then we'll just fight that dragon when it comes up. But in the early 1990s, Kent Beck and another group of developers started rethinking all this best practice stuff that existed in software and started questioning all these things and going back to things that he knows and he and his group of friends knew worked well on projects. So testing was a good example. They had a good correlation between, well, it seems like the more tests you have, the better quality code you have. So what's the most extreme version of that? We'll write the test before we write code. These were, of course, the extreme programming guys. And one of the things they observed was, you know, on projects where we do integration much more eagerly, we have a lot fewer integration-based headaches, and we put it off until the end and try to handle it all at the end. And so they invented this idea of continuous integration. Now, people who are in traditional projects heard about this continuous integration thing. They thought it was a terrible idea because everybody knows that the integration phase of the project is the worst part of the project. If you force everybody to do that every single day, that makes every day the worst day ever. But they learned something interesting that actually pervades a lot of engineering practice and software, is that if you handle it incrementally every day, it never grows into the dragon you have to slay at the end of the project. A lot of things in software work that way, and that's this idea, of course, of continuous integration. That you're using version control in some sort of canonical integration server, and that as a developer works on new features, they will test and make sure all those features work correctly on their local workstation. Once they make sure that their new features are working correctly, then they pull changes from other developers from version control and make sure that all their new features work with all their combined features. Once that's true, they push to version control, which kicks off a build in the continuous integration server. And once that finishes, you are said to have continuously integrated your code. And so if you translate the XP guy's mantra to modern terminology, it says that everyone commits to trunk at least once a day. That's the idea of continuous integration. That's the practice. But we don't even think of continuous integration as a practice anymore because we have all these fantastic tools to do it for us. We have Jenkins and Cruise Control and Bamboo and TeamCity and all those fantastic tools, but this is still a practice as well as a tool suite. And a lot of you have accidentally thrown this very useful practice away because one of the things about software is there's almost never a pure binary decision about anything. Everything is always a trade-off. And so what a lot of you have done is traded off one set of engineering practices for another, and I'm going to convince you you made a bad deal. And I'm going to show you how to undo that bad deal. So let's talk about a really common scenario that many of you are living in right now. So let's say that you have a reasonable version control system that has an idea of a trunk or main line of development. But there are a couple of features that you have that may or may not make it into the next release of your software, and you want to decide late in the process, should we include these features or not? So one way to model that problem is to use branching in version control. This is an engineering practice called feature branching. So in this scenario, Professor Plum has created one speculative in-flight feature, and Reverend Green has the other one, and they start working on their stuff. Now, both Professor Plum and Reverend Green, having been around the block a few times, know that as you work on things, you should periodically pull from trunk to take any changes, because we're still doing mainline development on trunk, so occasionally you'll pull from trunk and handle any little merge conflicts that come up. A few weeks go by, maybe a couple of months go by, and it's decided, you know what, we love Professor Plum's feature, we want it on the trunk, and so he pushes to the main line and performs a merge ambush on poor Reverend Green, who came into work on Monday morning, did SVN up, and now slam, he's got a month's worth of merge conflicts to deal with, which really sucks for Reverend Green. This is the problem with doing feature branching, because you did feature branching, and by doing so, you threw away continuous integration. Because if you're living on a branch, you are by definition not integrating all your code with everybody else's every single day. And so this is not what we want. We'd much rather have a set of practices around this idea of trunk-based development. And my former colleague, Paul Hammett, wrote a bunch of entries on his blog about this, so much so that he ended up spinning up an entire site about this called trunkbaseddevelopment.com. Paul Hammett has a lot of examples on here, and he talks at length about this mythical company called Bookface, and how they manage all of their stuff, which is, of course is modeled after Facebook, because he did a bunch of work there and understands their ecosystem. So here's the idea of trunk-based development. So let's talk about feature branching versus continuous integration with trunk-based development. And first of all, the three big problems with feature branching. The first one we already talked about is the inevitable big scary merge. And the longer you stay on that feature branch, the worse that merge is going to be. I was just talking to a client recently that tried to reconcile an over a year-long branch back into the trunk, and they eventually gave up and threw it away because it was going to be more work managing the merge conflicts than it would be just to re-implement the functionality from the ground up. That happens a lot. So we know that's a problem, but there are two other problems here too. If you're living on a branch, let's say you're Reverend Green, and you bump across the fact that the customer class is misspelled. Well, as a good engineering citizen, you really should fix that misspelling so that you don't have to deal with that in the future. But if you do, you're going to get punished hard, because now you got to either merge your branch in now and handle all the merge conflicts, or wait for another few weeks to merge it in. And that's exactly the kind of merge that drives you the craziest, because you incidentally touch like 40 different files that have customer in it, and now your merge conflict is that much worse. So what do? You just don't do the refactoring. What you've done is set up roadblocks and hazards for everybody trying to do the right thing. If you do the right thing, you're going to get punished. Therefore, I'm not going to do the right thing. So that's a bad problem, is it discourages opportunistic refactoring because you're living on a branch in isolation. Here's the other problem. So what I want to pitch is this idea of a feature toggle. And the way a feature toggle works, I'll show you a bunch of implementation details on this, but at its core, what a feature toggle is a little chunk of code that says, if this condition is true, then execute this code, otherwise execute this other code. That's all a feature toggle is. So let's say that we implemented these two speculative features using feature toggles. Reverend Green has a feature toggle, and so does Professor Plum. Reverend Green always leaves Professor Plum's turned off. So he only sees the stuff he's adding, same for Professor Plum, but the day they both touch the same class, you get a merge conflict right away, because they're both on trunk. They're not seeing each other's code because they're in conditionals that they never execute, but they're still integrating all the time, every day. And so this makes it really easy to combine features. So let's say you're living in the feature branching world of Professor Plum and Reverend Green, and the big boss comes along and says, okay, I want to see trunk plus green, trunk plus plum, and then trunk plus green and plum, go. Well, to make that happen in the feature branching world, you have to do 3 merges and manage all the conflicts and get all that stuff to work. And if he comes back next week and wants the same thing, you've got to do all those merges again. If you want to see combined features with feature toggles, you just turn on the ones you want to see working together, because you've already pre-merged all the code. In fact, I will guarantee you that if you use feature toggles, you will spend the least possible amount of time managing merge conflicts on your project. Because literally, as soon as you could possibly handle that merge conflict, it's going to pop up because you're integrating aggressively on trunk. So it's really easy here to combine features. Now, but let's talk about the problems here. What about things like cherry picking? This is the problem that we originally started with here. Well, this is just, now you implement this with a feature toggle, and you decide to turn those on or not, depending on the conditions of whether we decide to implement this or not. What about things like untrusted contributors? One of the best practices that some projects have is by letting junior developers, force them to check into a branch so that some senior developer can tech review all their code before they bless it and allow it into the magical trunk of your project. But all you're doing is artificially inflating merge conflicts when you do that. Because the longer it waits for code review, the chances of a merge conflict are going up and up and up. Why not let them check in to trunk underneath a feature toggle? No one will execute any of that code because you'll never turn that feature toggle on. Now, if your developers are so bad that just the act of checking into your repository breaks your application, then you have much bigger problems than feature toggles and feature branches. As long as it compiles, it works, because you're never going to go down the conditional until you bless it and say, okay, this code's ready to go. And so isolating changes on branches is just another way of inflating merge conflicts and preventing continuous integration. So let's talk about some implementation details for this. One of my colleagues, Pete Hodgson, has done a really nice write-up on Martin Fowler's website about feature toggles, and I will use a few of his examples. And here's the simplest possible form of a feature toggle. All these code examples are in JavaScript because JavaScript is eating the world. So let's say that I'm building an online game. And many of you know that one of the most critical functions if you're building an online game is to reticulate splines. This is an inside gamer joke that doesn't mean anything. There was a game. Does anybody know what game this started in? What game was it? SimCity would put up this thing saying reticulating splines, which sounds really official, but all they're really doing is loading crap in the background. So it's this made up thing. But so let's say that it was a real thing. So we have a current function in our code base that does reticulating splines. Looks like this. I'll zoom in on that a little bit. So currently, there's our current implementation. Now I want to build a new one, but I want to test the new one to see if it's going to work. And so the simplest possible kind of feature toggle is I have a flag here. This is new algorithm, true or false. And now if you use new algorithm, then return the enhanced one, otherwise return the old-fashioned one. That's the simplest possible kind of feature toggle, but very limited in functionality, of course, because it's within a function. And so one of the first things you end up doing is abstracting this out into something like a map and creating a function like feature is enabled something and then return the enhanced one versus the other one. This allows you to make the toggle dynamic. And you can now look at that toggle from multiple spots of your code base to decide whether it executes some functionality or not. This is what's referred to in the feature toggle world as a toggle router. And a lot of the frameworks that I'll show you come with a toggle router that will allow you to call from many locations in your code base to decide should this feature be turned on or not. One of the really nice things about using feature toggles rather than something like feature branching I alluded to before, which is easy testability. So here's a cucumber test in JavaScript that tests one side of my new algorithm by setting it false to test the old one, and then test the other side by setting true to test the new one. And so I can easily test both sides of it because both versions of the code are there. It just depends on the state of that flag that I set. So the idea is that you disperse feature toggles all through your code, and I'll talk about the granularity of these things in just a second. You usually rely on something like a toggle router. That can have some intelligence built into it as to who gets what thing, and I'll show you the frameworks, the way that you can build intelligence into this, including things like making determinations based on context about who's making a request for this particular feature toggle. So one of the pieces of advice that we gave on the ThoughtWorks Technology Radar a few radars ago was a piece of advice that says to do QA in production. Now, we're not suggesting that you turn your users into your QA staff, but if you could roll out new features into production, but underneath feature toggles that only your QA department can see, then you're effectively doing QA in production. A lot of companies struggle with coming up with a realistic production-like environment. It turns out you have a realistic production-like environment. It's called production. You don't actually have to have a fake one if you can use the real one to test new stuff. So I'm a consultant, and it's almost never does it happen that you get just the perfect problem and perfect solution that fit together like Lego blocks with one another. But recently I was chatting with one of our clients. They said, okay, here's our problem, which can't figure out how to solve. They host a service, and they have two kinds of clients. They have two mega clients, and they only want updates twice a year, and they want things to be as rock solid and stable as possible. They have about 15 smaller clients, and they want features a lot more aggressively, and they're willing to put up with a lot more buggy code if they can get new features a lot faster. How can we possibly model this complex scenario? Well, it's easy. You build feature toggles. You turn on feature toggles for your 15 smaller clients and let them test all your code. Then when it comes time for your big clients to get it, you just turn the feature toggles on for them, and now you've let all your smaller clients beta test and beat it to death before you actually give it to your bigger clients. You know, most companies who are doing continuous deployment are not barraging their users with brand new features all the time. They're doing continuous deployment underneath feature toggles. And the reason they're doing that is because that lets them get code into production as fast as possible to make sure that it plays nice, it deploys correctly, it monitors correctly, it logs, it doesn't eat up resources and other sorts of stuff like that. And by doing that really aggressively like that, when it comes time to do a big bang release, you just turn on feature toggles and a bunch of new features show up, but it's way less risky than trying to do a big bang deployment because you've gradually seeped those things into production over time and have been able to test behind the scenes the whole time you're doing that. So let's talk about 4 different kinds of feature toggles here, and these are differentiated by how long they live in your code base and how dynamic they are. In other words, how much do they look at the context of the request to decide who gets what. And I'll talk about 4 different kinds here. The first of these I'll talk about are release toggles. These typically last either days or weeks, and they change with a deployment. They don't have to be particularly dynamic. So have you ever wondered how projects that do continuous deployment do release branches? Have you ever laid awake at night, staring at the ceiling, wondering how can this possibly be? Well, obviously they don't do release branches, but that's something a lot of people do branches for, even if they're not doing feature branches. Isolate the changes onto a release branch so that you can make sure you know where all the ducks are, et cetera. What continuous deployment does is do a release toggle instead of a release branch. In fact, a lot of these frameworks will let you nest toggles into categories. So you could create 3 toggles that constitute the next release of your software and then just turn on the parent one, and you turn them all on or turn them all off at one time. That's how you do release branches in continuous deployment, is you do release toggles instead of branches, and that still allows you to get things into production as quickly as possible, but it also lets you control the release in exactly the way you want to and not beat your user to death with constant streaming new features. So this allows you to do trunk-based development all the way out to continuous deployment. This also allows you to do in-progress feature verification, because if you already got all this stuff out into production, why not just turn the feature toggles on for QA and let them check it out in a production-like environment? You will sometimes deploy incomplete or untested code paths here, but that's okay as long as you have really good discipline about having toggles in place. You're not going to stumble into that code, and I'll talk about how to prevent that in just a second. This means that you may actually have code that will never make it into the code base in production. So you may be working on some feature and it gets live underneath the feature toggle, and you later decide, I don't really want to implement that feature, and you get rid of all that code, but that's okay because you're never going to execute that code. You know, financial institutions are traditionally very trepidatious about, crazy engineering practices like this, but we finally convinced one of our financial clients in Manhattan to start doing feature toggles in production by finally convincing them, look, the if statement in Java always works. If that stops working, we got much bigger problems than deployments and feature toggles. So as long as I can convince you that all the code that you don't want to see is always underneath an if statement that will never execute, then we're fine. And of course, they're excited about this because now they can do multivariate testing and a bunch of other stuff they wanted. So that's one kind of toggle, release toggle. The next one are experimental toggles. And this, of course, is the hypothesis-driven development side of the world. This is the thing that lets you do multivariate or A/B testing, putting 2 similar code paths side by side and learning from your user about which one is executing. This typically uses a toggle router of some kind, so you can sprinkle toggles throughout your code base. The typical lifetime of one of these guys is hours or weeks. The real determination of the lifetime for one of these is how long is it going to take me to get useful experimental results. So Google uses this technique to test new search algorithms. When they want to test a new search algorithm, 1% of users into google.com get the new search algorithm, and if you end up clicking higher on the results page than people got the standard search algorithm, they view that as a better version of a search algorithm. One of the nice things about Google is that 1% of your users is still a gajillion users and is statistically significant. If you only have 13 users, you're going to need to run this experiment a lot longer to get statistically significant results. But that's the thing that determines how long this thing should live, is how long is it going to take me to get useful results out of this so I can act on them. And these are extremely dynamic. Notice these go all the way to the end of the dynamic scale over here, because a lot of these will look at the context of the request to decide should they get this particular feature toggled on or not. You'll be able to download these slides, by the way, if you want to save your film, because I know it's a precious resource on the phone. The third kind are operational toggles. These are meant to be permanent parts of your code base, and these are typically used for 2 kinds of things, either really short-lived little things like, for example, moving from one data center to another, and I don't have to code that everywhere, so I'll create one thing that says data center, just feature toggle back and forth between those guys. Or you may have some kill switches in place. So for example, Facebook has some kill switch kind of feature toggles where up to a certain level of scalability you get live results, but once you hit a certain level of scale, it switches over to cached results. It can switch back and forth. That switch is done with a feature toggle, not some sort of router or something like that. And in fact, at Facebook, they have a taxonomy of feature toggles. They have operation feature toggles that developers never touch and don't care anything about, and they have developer feature toggles that operations never does anything with. So it is possible to have several different groups of them that work independently of one another, and they've certainly gone down that path. And the last of these are permission toggles. And these are things that allow you to create a product experience, a premium version or an alpha version of your product. These are basically permanent parts of your code base. So this is the idea of I'm going to give you a free version of my software, but if you'll send me 1995, I'll turn on some really slick stuff in it. You can do that all with feature toggles, deploy the whole thing, and then just find a mechanism to turn those feature toggles on. You can build entire code bases like this that use toggles to change behavior, workflow, or visuals, or anything like that. So when you look at these feature toggles, in terms of static versus dynamic, the release toggle is really the most static of these. You can afford to change these every time you do a deployment. You don't need to look at the context of the request to decide whether you get this or not, unless you're doing some sort of specialized QA and production kind of thing. The rest of these have at least some sort of dynamic element typically. The length of time that these guys live moves from days to weeks for release toggles and things like experiment toggles, and then more to permanent parts of the code base with operational permission toggles. So let's talk about some implementation techniques. And so here is an initial kind of stab that you might make to implement a feature toggle. So we have constants. So let's go fetch some feature toggles from somewhere from our toggle router. And now I'm going to create generate an invoice email. So I go grab the base email, and then I say if features is enabled next generation e-commerce, then return add order cancellation to email from the base email. Otherwise, just return the base email. And this will certainly work. The downside of this, though, is that we've squirreled a whole lot of really hyper-specific detail into this little function. So why should the invoice email code need to know that order cancellation content is part of the next generation feature set? That's convoluting a whole bunch of concerns in one place right there. And so one of the common things that you do here is start doing some levels of indirection here. And so now I'm going to create feature decisions from here, and this returns if features is enabled or not based on what this flag is. Now I go fetch my feature toggles and I create feature decisions. Now my decisions have the option as to which one of these that I want. I've gotten rid of that magic constant in my code, and now I've moved all the actual toggle details up into create feature decisions. This is basically the classic level, give me one extra level of indirection. But there's still a problem here. There's still too many details here, because now our invoice emailer is responsible for asking the feature toggling framework how it should do stuff. And so the typical way that people solve this on projects is to say, look, we're going to do feature toggles in a bunch of different places. This is really just a form of dependency injection. So why don't we just inject feature decisions into everything that we create, and part of feature decisions is toggle state. And so this is create invoice emailer up here, which has the old version. The feature aware factory down here can say invoice emailer, return that and include whether this is the feature decision has this flag set or not. And so this is a way of doing dependency injection in JavaScript. The nice thing about feature toggles in all of their implementations is the ease in which you can test either side. And so this lets me test where the order cancellation is true, and then this will let me test the side when it's false. You can also, if you want, this is basically just an example of avoiding conditionals by injecting decisions as a dependency into the thing that creates stuff, and then you can rate things off of decisions. You can also use things like Spring to do this. Notice that's exactly what dependency injection is designed for. Inject this dependency or this dependency based on some criteria. If you have an interface that governs the behavior of both of them, then you have an easy way to manage that completely from the infrastructure level if you want to, particularly for things like server-side code. So let's talk about some very specific engineering practices around experimental toggles. And one of them is you want to remove these things as soon as the feature decision is resolved. So when I put on my engineering hat and look at feature toggles, what feature toggles are is purposeful technical debt added to support engineering practices like continuous integration. Make no mistake about it, this is technical debt that you are adding to your code base on purpose. And here's the trap that everybody falls into. If you do a Google search for feature toggles, the first page of Google results are exactly like this. Feature toggles are one of the worst kinds of technical debt. And every one of these stories reads the same, which is we got super excited about feature toggles. We put a whole bunch of them in our code base. Then we got distracted by something else. And now we're mad that there's so many feature toggles in our code base. So they're basically saying we added a lot of technical debt to our code base, and then we got really mad that there was so much technical debt in our code base. It's like, well, yeah, that will probably happen. So one best practice in this world that we implement all the time is as soon as you play a story card that includes a feature toggle, insert a downstream story card that says remove this feature toggle. It is now in your backlog of things you need to do, and as the tech lead, you want to be aggressive about pulling those things out as quickly as possible because they are technical debt, and you want to get rid of them. One of the nice things about one of the frameworks I'll talk about in a second is Toggle Z in Java that lets you tag all of your feature toggles with a unique attribute. And that makes it super easy to clean them up when you're done because in your IDE, you do find usages for this attribute and every single thing affected by that feature toggle shows up in that list and you just go in and kill off the parts you don't need anymore and it's easy to clean them up. It can't be overstated, this is the biggest hazard in feature toggles. And I'll tell you a little parenthetical story here. This is actually a fourth case study. I'm doing a talk this year, maybe do it at DevNexus. We'll see if they choose this talk or not, called Stories Every Architect Should Know. And one of them is about Knight Capital. And if you ever want to Google this story so you can look at it, go search for the Google phrase bankrupt in 45 minutes, and you'll find the story that I'm talking about. And so here's the danger of using something like feature toggle. So Knight Capital was this financial firm, and they had this old way of calculating the way they were buying and selling stuff called PowerPeg. And PowerPeg was way outdated. They had implemented PowerPeg under a feature toggle, but then when they stopped using PowerPeg, they just left that feature toggle in their code base because, what could go wrong? Then a new way of buying and selling stuff was mandated by the Federal Trade Commission called SMARS. And so they had to implement SMARS. And so one of the developers said, hey, we've already got that PowerPeg feature toggle. Why don't we just implement SMARS underneath the PowerPeg feature toggle? Because what could go wrong? So they got all the SMARS code written, and it came the day they need to roll it out, and they updated the code on 7 of their 8 servers. This is the danger of not automating your DevOps, kids. And then they went live, and they turned on the feature toggle. For 7 of them, it started doing SMARS stuff, and one of them started doing PowerPeg, because all that code was still there, latent, and now they've turned it on. And what SMARS was doing is selling, and what PowerPeg was doing is buying. And they panicked. It's like, why is it doing this? It's not supposed to do this. It must be the deployment. And so they rolled the deployment back on 7 of the machines, but left the feature toggle on, which means it started buying even more aggressively. In 45 minutes, they essentially just pull the plugs out of the wall to make their servers stop doing this. And a venture capital firm had to write them a check for $300 million. Because that's how much they were in debt by the time this little excavate finished. The only reason they're still solvent is because a venture capital company wrote them a check for $300 million. That's bankrupt in 45 minutes. And there's a whole cascade of awful things you should never do on this project. One is don't leave ancient feature toggles in place because it's just technical debt waiting to nab you. Number 2, never, ever, ever reuse an ancient feature toggle for some new thing. You know, they're really expensive. You know, it costs so much to create a new one versus an old one. You know, I don't know, there's a lot of cost involved there. And number 3, of course, is automate your DevOps stuff. If any one of those 3 things hadn't been true, then they would have had just a bad day, not a catastrophic day. So get rid of them as aggressively as possible. That's the biggest stumbling point for feature toggles, is leaving them in your code base when they shouldn't be there. You will have a bigger testing scenario to deal with, because notice that toggled one side, you're taking one complete code path, and the other side, you're taking a complete different code path, so make sure that you account for that. It's also a best practice to don't create toggles that depend on other toggles, because this is the pathway to insanity. You'll never figure out how anything works anymore if you do this. This, in fact, is one of the things that I find most prevalent with the extensive use of feature branching and really in version control systems. that they have a lot of really complex branches, and branches depend on other branches, et cetera, so that it's really hard to figure out how to actually build something in your code base. And I think part of that is, and I've identified this before in other contexts, but if you really boil it down to its essence, what many of you do, if you try to describe your job to your grandparents, is you take things from web pages and put them in databases, and you take things from databases and put them on web pages. Yeah, there's a bunch of details and moving parts in there, but if you look at the edge cases there, that's kind of what it is. And developers who've done that for 20 or 30 different projects, it gets kind of boring. Do you know what developers do when their day job is boring? They invent cool puzzles to solve. And that's what a lot of companies use feature branching for, is the cool puzzle that you have to solve every day to actually get anything done, is figure out what is this Byzantine set of branches doing and how do I make all this work? And it's a great way to distract yourself from doing the thing you're supposed to do. This is what I refer to as meta work is more interesting than work, because that's really just meta work, and that's way cooler than actual work. Feature toggles work on pretty much any technology or platform, any technology stack that can support an if statement and can read external configuration. And I'll talk about one problem child in just a second that doesn't support that, but there's a way around that too. They're also really, really common. So I've done a talk about this for many years around my continuous delivery workshop, and the feedback that I usually get from this talk is either, wow, I can't believe anybody does that in production. That seems so crazy. Versus, why are you talking about something so old? We've been doing this for a decade now. So the first ThoughtWorks project to ever do this was 2003. So we've been doing this for a really long time at ThoughtWorks, and have had great success with it. It's a good advantage to take advantage. It's a good idea to take advantage of structured configuration files. Most of the frameworks I show you have some version of this, which lets you tag some additional information onto your toggles, because if you create a toggle with this constant, and then 6 months later you're looking at going basic rectangle algorithm, basic recreation algorithm, basic, I don't know what this feature toggle was for, but if you're using some sort of structured map or something, you can put a description about what the thing looks like. So let's talk about building a toggle configuration, and you can do a bunch of different ways for this. Of course, if you use one of the frameworks I'll show you in a second, they already have this built in. The simplest case is just hard code your toggle information right in your source code. This works if you have a very limited scope or you're in a single technology stack. If it's all within one method, just create a variable within that method and toggle back and forth. You'll almost always go to parameterized though, some sort of map, some sort of name value pair, so you can keep track of more than one toggle at a time. The next escalation is toward a configuration file. This is common if you need to support multiple technology stacks. So for example, single page JavaScript application, Java backend, they may need to share toggle information because they need to know and react on both the user interface and the server side code. And so several of these tools support that. If you've got a database already, there's nothing wrong with putting your toggle information in the database. It's just another bit of data that your application needs to rely on. And if you want to go super fancy, you can use one of the distributed asset management tools like Console or Zookeeper, which are common in the kind of microservices space, but these are basically big giant distributed name value pairs, or they can be used as that. And so this is a place you can put your toggles as well. I probably would not go all the way to Zookeeper just to manage toggles, but if you've already got Zookeeper there, then it's a perfect place to add toggles as well. So let's talk about some of the frameworks, including one that I've used a whole bunch called Toggle Z. This thing has been around for a really, really long time. It's been used a lot. And one of the cool things about Toggle Z is a variety of activation strategies that it offers. So one of them is by username. So if you know exactly what the username is, that's one of the activation strategies. I'll talk about gradual rollout in a second. Release date allows you to set an exact release date and time for this toggle to come out. This is how a lot of release branch deployments work. Is say, okay, at 7 a.m. on Monday morning, I want these 4 toggles to go live. To your users, it looks like you just did a big bang deployment, but all you really did was turn on some toggles that you've hopefully already tested to make sure they all work correctly. You can do this based on IP address, client or server IP. There's also script engine, which basically lets you write any sort of expression that returns true or false to decide, should I let this person see the toggle on or not? So it can be arbitrarily complex if you want that to be. I want to talk for a second about the gradual rollout thing, because that actually corresponds directly to a DevOps engineering practice. So let's go to the operational side for just a second. and talk about canary releasing, because that's really what gradual rollout is. So this is a well-known DevOps practice, and the idea is that you got lots of infrastructure, you got lots of users, you want to roll out some new functionality, but you're not sure if you want to roll it out to all the users at one time. Maybe you're worried about scale or latency or something. And so you want to roll it out to a subset of your users before you roll it out to the whole group. That's the idea of a canary release, based on this idea of a canary in a coal mine, where you can roll this out to a subset of your users and then decide if you want to roll it out to the rest of your users or not. And that's exactly what gradual rollout from Toggle Z allows you to do. So Toggle Z comes with a filter servlet that you can put in front of your application, and in the Toggle router you can configure it to say, okay, for this particular feature, let's do gradual rollout. I want to roll it out over the course of 5 hours. So in the first hour, 20% of people will get it randomly turned on and 80% will get it turned off. In the next hour, 40% of people will get it randomly on and 60%, so it'll gradually roll it out for you to random people as they come into your application. And the idea, of course, is you're monitoring or logging and making sure that, as the number of users, the number of capabilities expand, that you're able to handle that. This is used for a lot of things to reduce risk of release, because you're rolling out something that is going to have some sort of risky impact. Performance testing is a really common use for a canary releasing something. I have something that may have a performance impact if everybody hits it at the same time. And then, of course, this idea of multivariate testing, which we'll poke around on a little bit more in a second. So this is an example of how Facebook rolled out chat. This is a big deal for them, because they're going to let Facebook users chat from one to another, and that could have a big impact on their infrastructure. So the way that they rolled out chat was they dark launched all the chat code worldwide underneath a feature toggle. And then on the morning they were rolling out chat, they turned that feature toggle on for New Zealand. They picked New Zealand for two reasons. One, it's the first country to get sunlight, and they have a relatively small number of users in New Zealand, so that gave them a good initial spike of what that's going to look like. Australia was next, and they have a fairly large number of users in Australia, so they basically just chased the sun around the world. As sunrise hit a region, they would turn that toggle on for that region. That allowed them to save their most complex, busiest region, the US, for last, and they decided as the sun hit the East Coast, should we go ahead and roll it out? Things looked really stable and good, so they rolled it out. So over the course of 24 hours, they rolled out chat, kind of cascading across the world by turning on feature toggles by region on a case-by-case basis. One of the nice things that Toggle Z supports is this taxonomy and the ability to group several things together under a feature toggle, so you can just turn one toggle on and it actually affects a bunch of different things. There's an example of the annotation stuff, or the attribute stuff I was talking about. There are a bunch of other frameworks that help you do this. So here's a page from the Beautiful Bills website that lists a whole bunch of feature flags, 4 different ones in Java. There's Python, .NET C#, Ruby, and Ruby on Rails. I'll show you a JavaScript one here in just a second too. The other Java one that's really prevalent and is used a lot is this thing called FF for J, or feature flags for Java. And it has a bunch of friendly, they're all open source, of course. This has a bunch of friendly goodies in it, so it has a really nice page where you can turn things on and off dynamically if you want. This guy already has pre-built to let you store your toggles in a variety of different places, like a JDBC database or an in-cache or Redis database or Neo4j. The other cool thing that FF4J will let you do is if you already have access control lists, you can toggle based on your ACL. So if everybody in your QA department is on the same access control list, then problem solved. You just release this toggle, let the QA in, let everybody else out, and you're doing QA in production. So if you've already got that definition in place, you can easily take advantage of that. You can get some statistics and reports and things on what's going on with your toggles, how many of them have been followed, etc. It'll also let you cache your toggles. So if you store them in a database, you can cache them to get better performance if you have latency for that. There's a JMX plugin for it, and there's also a bunch of other reporting and dashboards, etc. So really nice bunch of slick features for enterprisey kind of feature toggle stuff. Pretty much any framework that you think of will have feature toggles. So here's one in Ruby on Rails called Chili. The way you activate one of these guys is based on we build a module and then active if, whatever criteria you want that to be active under. Here's a very, very simple one from the JavaScript world that is basically just gives you a feature toggle in the JavaScript that you can take advantage of. Here's one in Angular 1 that creates a new feature flag hide attribute in Angular. There's also one for Angular 2, and then there's one for Angular, 12, 13, 14, 15, whichever one is the next one. Yeah, that one. There's one for that too. Yeah, so whatever the next number for Angular is, it's that one. They've ceased to count serially in the Angular world for some reason. So let's talk about the problem child. So all the criteria I laid out for platforms that support feature toggles can read external configuration and has an if statement. What's the thing that everybody in this room is using all the time that doesn't support either of those two things? A relational database. And this is a problem because there's not a great if statement in a relational database. There's a conditional, but it's kind of not great for this purpose, and reading external configuration is tricky. And so your best bet, if you can avoid it, is just toggle around the database. So have a feature toggle that says, use this view or this view, and just avoid the database entirely if you can, but then you're going to run into this. What if you have 3 applications that are using the shared database integration pattern from enterprise integration patterns, where the shared database is the integration point? Many of you are also in this situation. And this now is creating a problem, because what if I need to create a feature toggle that needs a schema change on behalf of one of these applications but not the other 2? This, fortunately, is a solved problem in this book. And I want to highlight this book because it just had its 10-year anniversary. This is the Refactoring Databases book by Pramod Sattelage and Scott Ambler. And you can't actually see the subtitle there, which is, I'll tell you what it is. But I saw Pramod recently, and I told him, you need to re-release this book and make one minor change to it. And that is flip the subtitle and the title. The subtitle of this book is Evolutionary Database Design. Would you not run out and buy a book right now called Evolutionary Database Design, subtitle Refactoring Databases? Well, it's there. It just came out 10 years ago and it was mislabeled. So there it is. Everybody and their brother needs to know how to evolve their databases now that everybody's going after microservice architectures. And it turns out that Pramod and Scott described exactly how to do this about a decade ago. So this is literally a book that was just about a decade ahead of its time. But they also talk about how to untangle this particular problem. So here's the scenario. Let's say that this is my setup, where I have balance on customer and I want to run an experiment where application A, and only application A, needs to have balance over here on account instead of on customer. But how can I possibly do that without breaking B and C at the same time, because they're all sharing the same schema? Most of these database refactorings have what's called a transition phase, and this is the transition phase for this particular refactoring. So what I'm going to do is go over here and add a balance column on account on behalf of application A. Then I'm going to create a trigger so that any changes that happen over here get replicated over here and vice versa. I now support both schemas. I'm living in a world where balance lives on customer, and I'm living in a world where balance lives on account, and I can live in this world as long as I need to until I resolve this experiment and decide, should this be a permanent change in my code base, in which case I'll carry through for this refactoring, untangle A, B, and C from one another, and fix up all the stuff, or if this is a failed experiment, then I can just collapse this toggle and not have to affect any of the applications at all. So this is a good temporary way to test something out without any sort of permanent long-term damage to my code base. If I decide to actually carry through the refactoring, then the ending state gets rid of the trigger and gets rid of the old balance column and leaves the new balance column in place. So you can do this even in things like relational databases, using relational database tools, and the Refactoring Databases book, in fact, has a lot of techniques to do exactly this kind of stuff. So let's talk for a second about the architectural impact of things like feature toggles, because they will be pervasive in your code base. So one of the things I didn't mention before is that you don't want these to be little teeny tiny things. You don't want to support like 50 at a time in your code base because it gets way too confusing. You want 5 or 6 at a time maybe, and these should be fairly coarse-grained things. And they will probably pervade a lot of your code base. So for example, if you're in something like a layered architecture, you will probably have a feature toggle in every layer. because, every layer is going to have to react one way or to the other, depending on what condition is true or false based on your toggle. Things like microkernels, you can do feature toggles inside the core to decide, do I want to include this plugin or not, or within a plugin to change behavior for a discrete plugin. In microservices, you typically don't even have to use feature toggles if you don't want to, because you can get the exact same effect just by selective routing. So let's say that I put a new service live that does something almost the same as the other ones. I just don't route to it yet. I can now selectively start routing to that, and that gives me the same effect as a canary release, but without using a feature toggle framework. So things like microservices typically use intelligent routing to decide between two features versus something like a feature toggle framework, but the end result is the same. And the same is true for things like service-based architectures. You can put feature toggles inside any one of the pieces here. Some of these architectures are easy to do this. Certainly microservices make this really easy because the functionality is really granular, and that makes it easy to toggle behavior very discreetly. Which brings me around to this idea of an evolutionary architecture. This is one of the supporting elements that you have to have for being able to do things like feature toggles. And this is our definition. So this is a book that I'm literally just finishing up. In fact, I left my house and I'm finishing up copy editing on this book now to come here. And when I leave here, I'm going to finish up the copy editing on the Building Evolutionary Architectures book, which will be out in mid-September from O'Reilly. It's already available on Amazon. So you should go now and make sure you order 2 copies in case you lose one, because you don't want to be without anything. So we're thinking about how do you build architectures that support change. And that's his idea, and this is one of the building blocks, of course, for hypothesis-driven development. And so here's our definition of an evolutionary architecture. It's one that supports incremental guided change as a first principle across multiple dimensions. And I won't go deep into this definition. I just want to talk about the parts that are particularly pertinent to this idea of hypothesis and particularly data-driven development, because I'm about to give you a good example of an evolutionary architecture. And one of the things that we talk about in that definition is the idea of incremental change. And incremental change really has 2 meanings in an evolutionary architecture. One of them is on the operational side, and this is what I want to talk about now. So imagine, if you will, a modern 21st century architecture with really good DevOps and something like services, or this could even be a modular monolith, but really good separation between the bits, the components of my application. It is quite common in this world that we have decoupled component deployment from feature release. This is one of those things that most of you, when you deploy your component, you're also releasing that feature, which means you're doing 2 things at one time. Well, if you can separate those things, you actually cut down on the risk because you can do those things independently from one another. So that's really common in this world. You can deploy components, but features are still nestled inside them, not turned on, and at some point later you can turn on those features by turning on a feature toggle or starting to route to that service, for example. Because it's quite common, particularly in service-based architectures, that applications really consist of routing. And here's what we mean by incremental change at the architectural level. We have a fake corporation in our book called Penultimate Widgets, which is the next to last widget manufacturer, but they're trying to get better. And they have this exact scenario where they have a catalog page that they're selling their widgets for, and they allow users to star rate their widgets. So they have a star rating service running within their architecture. And then one day, they release a better star rating service that allows half-star ratings and put it live. They don't force anyone in their ecosystem to start using it. This is just now a new capability that exists in their ecosystem. And so these other services, as they get time to do so, will start preferring the half-star ratings to the old one, and so they'll start routing to that one instead, until eventually no one is routing to the old star rating service anymore. One of the magic tricks that Netflix taught us about architectures like this is that you monitor not only the routes, not only the services, but also the routes between services, and any service that hasn't been routed to in a set amount of time, you automatically disintegrate it out of your architecture. This is evolutionary change at the architectural level, to be able to put 2 things side by side with slight differences and be able to decide which of those people route to and which one of those we eventually keep. That's really the structural underpinnings of how to do things like multivariate testing in something like an evolutionary architecture. That is exactly that capability. So let's talk now about the ideation side of this. We've talked about the implementation side and the DevOps side. Let's talk about ideation. And where this term comes from, if you do a search on hypothesis-driven development, Dr. Dobbs' journal had an entry for it back in the 90s, but it had nothing to do with what its modern meaning has. That was mostly coined by Barry O'Reilly in the book Lean Enterprise and on his blog where he talks about this. And his observation was basically this, that in the early days of software, we used to capture requirements like this. As one of these, I want this goal so that we can get this benefit. And then we did a whole lot of agile engineering stuff and invented a whole bunch of new ways to test things, fitness and behavior-driven development and all that. And we've advanced so far that now our requirements look like this. In order to receive this benefit as one of these, I want this desire. And that's so much better than the version that came before, because I mean, the version that came before is just ridiculous. But now this is really nice. His point is that this is exactly the same as what it was, that the ideation phase of coming up with ideas on projects, regardless of how you capture those things, hasn't changed that much. And it's not that different from big design up front, because you got smart people going into a windowless conference room and coming up with this list of things to implement. What made them so smart? How did they figure out exactly what your users want? They're just guessing, just like anybody else does. And so this is exactly what Barry's talking about. Once you have a minimum viable product, something that actually works, rather than having ideas and brainstorms about new stuff, why don't you start casting those things as hypotheses? So we believe that this capability, whatever some new capability is, whether it's a user interface change or some new back end, or some reorganization, et cetera, will result in some concrete outcome. So we're looking for measurable results here, and we'll have confidence to proceed when we see a particular measurable signal. So you always put some sort of threshold on here about what's going to make us decide to move one way or the other. So here's an example. Let's say that you're in a business analyst meeting, and one of the business analysts said, or one of the new requirements is, we should make the hotel images bigger on the catalog page, because I think that'll get us more bookings. Instead of doing that, cast it as a hypothesis. So we believe that increasing the size of hotel images on the booking page will result in improved customer engagement and conversion. We will have confidence to proceed when we see a 5% increase in customers who view hotel images, who then proceed to book in 48 hours. So we're going to put a different version of our site live for half our users. And they're going to have bigger images for the hotel site. And we're going to look and see over some set amount of time, maybe a week, which of those, otherwise random, is getting more bookings. And if that's the only variable we've changed, then you can make a reasonable assumption that bigger hotel images are leading to more bookings. So rather than just coming up with this idea, let's test this theory against our real users and see what's actually happening. This is exactly what Facebook is using. You know, their popularity is not accidental. They learn stuff from their users all the time and feed that back into the things they're building on their platform. So here's a great example of that. And this is a particular hazard that a lot of agile projects fall into, particularly ones that have been around for a long time. Because what happens is you create a mature agile project, but then you keep working on it. People keep having ideas. You keep adding more stuff to it. And this is exactly what happened in this company in Germany. These guys run an auto auction mobile application. And they are a mature agile project. And they keep getting requests from business analysts, and every request business analysts makes sense in and of itself, but when you put them all together, it starts creating a really complicated user interface, and then the worst possible outcome started happening. The number of users started going down. They said, whoa, we've got to decide how to fix this, but this kicked off this giant debate within the company. What do our users actually like about our application? And they came up with 3 hypotheses. More listings, if we get more listings on screen, then we get better comparability. Better structure, if we structure our listings better, that makes it easier to scan and we can learn stuff faster. Or is it better prioritization? If we learn a bunch of stuff about our users and prioritize a list based on what they really want, maybe that's what they'll like better. And what they did was create 3 different versions of the application and run the experiment. And I think they found out that better structure was the one that won by enough margin. Now they know as they add more things to the application what they should emphasize, because their users have told them what they like most about their application. It's really nice to be able to learn from your users like that. But here's the last case study. And this is a great example of both evolutionary architecture and data-driven development. This is from the GitHub engineering blog, and it's an entry called Move Fast and Fix Things. And this talks about a problem that GitHub encountered. Because it turns out since day one on GitHub, the way they have merged two Git projects is to shell out and to a shell script, have Git do the command line merge and then suck it back into GitHub. And that works flawlessly because Git knows how to merge two projects. Problem is it doesn't scale great. All this shelling out and shelling back in and passing stuff back and forth. And one of the side effects of GitHub is that they operate at such scale that one of these engineers said that every edge case appears almost instantly. And I'll show you an example of that in just a second. They also, by the way, average 60 deploys a day. So they're aggressively continuous deployment kind of organization. In fact, they do chatbot deployments. Their chatbot listens to them all the time. When they want to put something live, they just tell the chatbot, and then 5 minutes later it tells them, yep, deployed or did something wrong, etc. So they've got to fix merge. And so they bit the bullet and they wrote an in-memory version of merge in C. And they tested it, but now they have to put it live. And here's where the fear sets in. Because you can't break merge on GitHub. Introducing regressions into something that has worked flawlessly since day one is a bad idea with a capital B. So how can you possibly put this new code out in a safe way that doesn't accidentally break something you don't want to break? So what they did was created an open source, this framework called Scientist. If you go to the Scientist page, there's a port in about a dozen different languages, including Java and a bunch of .NET languages of Scientist in a bunch of different languages. And here's what Scientist does. You create an experiment block in Scientist where use is the old way we used to do it and try is the new way we're trying out. When it hits an experiment block, Scientist decides whether or not to run the try block. So for the merge experiment, 1% of users ran the try block. It always runs the use block and it always returns the result of the use block. So even if you stumble into this experiment, the worst case scenario is you get exactly the answer you would have gotten back if this experiment weren't running, but we're also running the experiment code so we can compare the results to see did it work the same way. So we randomize the order in which use and try are run, measures the durations, because we're measuring performance too, compares the results of try to use, swallows and records any exceptions, and then publishes all this information. So here's what happens when they went live. So this is a good example of the scale. So this is at 2:20 a.m. They're doing, 3,000-ish merges at 2:20 a.m. There are a few merge conflicts down here that you can't really see because they're so small. So let's zoom in on the bottom bit there. So there are a few mismatches. So these are ones that we did use and try, and they disagreed in the results. But the other thing we're measuring is performance. The green line here is performance, and the blue line is the old code, so clearly the performance is way better. But here are the bugs they found because of Scientist. One they found almost right away was that their code was going all the way through the file, whereas the command line Git, as soon as it hits a merge conflict, it bails and says unsuccessful. So they modeled that in their code. They had been doing this index write, which is causing a lot of time, but they realized they didn't have to do that anymore because it's all in memory, so they got rid of that. This is one of those edge case things. If the ancestor had a given file mode and one side of the merge had removed the file and the other side had changed the file mode, it would report successful merge. This is a bug in Git, so they posted a bug report to Git. This is the one, though, that would keep you up at night because it turns out that since day one at GitHub, if you give it two files that have exactly 768 merge conflicts, it'll come back and say, merge successful. What? So this is that edge case shows up almost instantly thing. And so why is this happening? How could this possibly be happening? Well, here's a clue. 768 is 256 times 3. Anytime you find yourself on a power of 2 boundary, that means there's some computer science shenanigans going on somewhere. And that's exactly what happened here. Remember what they were doing. When it comes time to merge a file, they're shelling out to Git to tell it to merge these two things. Where does it stick the number of merge conflicts? In the return value of the shell script. If you hit exactly the right number of merge conflicts, you overflow that variable back to 0, and 0 means successful. So if you hit an exact power of 2 plus 1 merge conflicts, GitHub will come back and say, yep, everything's cool, because it's stuffing that into the return value and it's overflowing. So they discovered a bug that had existed since day one, but it just, randomly people would get these merge conflicts. What the hell? Let's try it again. And so they fixed that even though they're replacing that code. The new library was skipping the entire step, so they found that bug and fixed it. So after 4 days of iterating on this process, they got the experiment to run for 100% of the request for 24 hours with no mismatches and no slow cases for the entire run. So they removed the old merge code and left the new merge code in place. So they replaced merge on GitHub with 0 regressions, and they incidentally found 3 or 4 bugs that were already existing in their infrastructure because they were running it in a really controlled way. All Scientist is a feature toggle framework. That's all that thing is allowing you to test those two things side by side and gather statistics on them. So it's just a feature toggle framework with some metrics built into it is all it is. But it's a great example of how you can make big time changes in a code base without breaking a whole bunch of stuff in the meantime if you can isolate those changes. And that's exactly the superpower I'm talking about. Once you have these engineering practices in place where you have good machine provisioning and deployment pipelines and the ability to do feature toggles with confidence that you're not going to break things, that is the superpower you get from having all these engineering practices in place. And this really allows us to put that last feedback loop in place, which really gets our user involved in the way that we make decisions about things. It is not a coincidence that Facebook is a very successful company. They're very successful because they constantly learn what you like and give you more of that. And that's the secret to a successful software company, is to figure out what users want and keep giving more of that and not be overt about it. You almost never get a survey. Take the survey about how you like this. They're looking at click trails and where you click on pages and that sort of stuff and doing a lot of analytics to figure out and do experiments on you to learn what you like. That's this idea of hypothesis-driven development. And all this really is, this is not some magical thing we've created. All this is applying the scientific method to software development. We know the scientific method works, and we can do that in software just like we can in science. That's exactly what this is. And it really leads to a new way of thinking about things. Once you have something like a minimum viable product, you still have a vision, strategy, and business goals. You still have ideation, but ideation now is really coming up with experiments to run. Because you're speculating, but I want to get confirmation that my speculation was correct. And so you create experiments. That creates a portfolio of ideas, and then you start working on these guys. You select an experiment and start working on it. And the classic case of, they like part of what we're doing and not the other part, and so that's the classic case of a pivot, where we start doing more of what they like and less of what they don't like. Maybe you start one of these work streams that seems really promising, but then you get 0 engagement. They treat it like vegetables, so you can fold without putting a lot of effort into it. And of course, what you hope is that you pick an idea that your users just really love, and you can really double down on that thing and put more resources into that and less in places that they don't want it. There's also a strategy that kind of takes advantage of this called set-based design, also in the lean manufacturing world. And the point in set-based design is, if you're trying to build an application that has several different possible overlapping feature sets, it may be too difficult to go from a single option into too many different variations of that. And so set-based design says start by building the thing and build all the things that we might want and filter those things down as you go. And of course you can model this on top of something like feature toggle so that you can hide those things that you don't want to see as you continue along the path. So this is another variation on hypothesis-driven development, which is really just this idea of using the scientific method to learn things about your users. So to summarize, this is really something that touches a bunch of different parts of software development, a bunch of engineering practices, DevOps, and ideation, but it's a really nice thing to have, and this is in fact a big selling point for your business people on let's get around to getting all this continuous delivery stuff implemented, because once you have all those things implemented, now you can start talking about multivariate testing, and that's something that business users really want, because they really want this ability to be able to learn from your users. This is the way to do that. That's all I have. Questions about this? Yes?
Do you have a minute to contrast feature toggles with branch by abstraction?
Yep, branch by abstraction is just a refactoring technique. that Martin talks about, which is basically, if I need to refactor this library away, rather than refactor it because it'll break my application, do it behind an interface so that I can make those changes without breaking everything. This is basically what domain-driven design calls an anti-corruption layer. So anytime you wire yourself to something, put it behind an anti-corruption layer. So there's both ways of being able to make changes to things. Branch by abstraction is usually more useful for behind-the-scenes kind of things where I want to let a team work behind an interface for a while and hide those results, whereas feature toggles are much more user interface centric and much more, they sprawl out in the code base a lot more than branch by abstraction typically does. But they're both overlapping techniques. Yep.
You got any advice on how to actually run the test you just described? So I showed this page to how many people? How do I know that they actually did the thing that you're trying to drive the business value?
So learning the things from them?
Yeah.
Well, there are tons of JavaScript frameworks now that do things like click tracking and click mapping and click trails and all that sort of stuff. We just implemented something, actually we're in the process of implementing this for one of our clients, basically a proxy layer that collects every single thing the user does as they touch their application in the browser so they can learn stuff from them. So there are tools out there that allow you to do that kind of stuff.
And those tools have the visibility into which flags were set, so you know what that user was actually shown?
Yeah, you can definitely wire the flags into that because you have a distinct kind of path to say whether this is on or not, so you can turn on the metrics per flag and have those associated if you want to. So there are a bunch of different ways to do that. I mean, this is the way that people learn stuff, so it's very common. Other questions about this? Yes?
How do you do toggles if I need different libraries versions?
Well, that you could do that as a branch versus by abstraction thing, but you're going to have to figure out how to, if you get the dependency stuff working, then you just got to figure out how to instantiate one versus the other in your code base. Java will fight you on this. This is why you need Java 9. In Java 9, you can do this. And you could probably get by with this using a Spring in some sort of clever way. But that's a tricky situation.
Yeah, but I mean, it's class, it's classes different.
Yep, so that's going to be tricky. So you're better off not trying to toggle around a library like that. That would be better for branch by abstraction, actually, if you're trying to swap those things out, but that's a much harder thing. I mean, it'd be really hard to toggle around a framework. So, I want to use Spring versus Pico container on this project. We'll build the largest set of toggles on earth to toggle between these two things. It's maybe possible, probably not advisable.
More like if my application uses another type of services.
Well, see, this is easier in JavaScript, so you're more likely to bump into this in the JavaScript world than you are anywhere else. But that's more likely there than anywhere else because everything. I've been making this bet. I've been meeting with a bunch of enterprise architects. I've been making this bet, and nobody will take me up on this bet. I keep betting. I'll give you $100 if you'll tell me what JavaScript framework you'll be using in 2 years. Nobody will take me up on this. I can't figure out. Aren't EAs supposed to be long-term planner kind of guys? I mean, come on. There we go. Okay, any other questions about feature toggles or anything like that? Yes?
You started out with trunk-based development, and that sounds like a way of aiding and abetting the bad practice of having feature development that's based on long-lived tasks.
No, those are not correlated. I mean, trunk-based development has nothing to do with the length of your task. It's just all on the trunk. If you're using your branch as a way to moderate how long it takes to work on something, you've conflated two things horribly.
If you have short tasks, then you have no need for long-lived feature branches.
That's correct. So there's a direct correlation between the length of your feature branch and how much damage it does to your code base. But I would say that I will guarantee you, if you use feature toggles, you will suffer the least amount of merge overhead on your project. If you're willing to endure merge overhead so you can play on branches, then that's fine, but there's a correlation there. So a good example of this, if I had a 2-hour fix, I probably would not create an entire feature toggle for it. I'd probably create a branch, fix it, merge it, be done. But there's a slippery slope there. Oh, I can fix that in 2 hours. And a week and a half later, it's like 5 more minutes, just 5 more minutes. I'm almost just 5 more minutes. And of course, now you're in merge conflict, not so. But if you started as a feature toggle, then no, we're always there. So I don't think there's any correlation between encouraging longer-lived tasks. I mean, if the fear of merge conflicts is the thing that's making people work harder in your organization, then there's some dysfunction there that should be attacked that has nothing to do with version control. Yep.
So you mentioned a little while ago that you start with an MVP and then you start your hypotheses. Can you start as part of your MVP? I guess you could do it to some degree in your MVP.
Oh, absolutely. So as much as you want to learn from your users. So, I mean, if you're building a bicycle, an MVP is not a wheel. But 2 wheels and a platform, that's close enough. So we can start. I would try to get the hypotheses as quickly as you can. Because the quicker you can start learning from your user, the less time you're going to spend building something they don't like, which is always a hazard if you're just coming up with ideas and building stuff. So the faster you can get them to start telling you stuff, the better off you are, I think. Yes?
So basically, the general idea is that if you want feature toggles to work out, you want to make sure that they're orthogonal. So the feature sets are orthogonal.
Ideally, yep. You may have to reorganize your project so that you don't have 2 that depend on one another or overlap or something like that. Because that, I mean, it's possible, but it just engineering overhead and collaboration. If you can organize things so they don't touch one another, then you're better off. You can't always do that, but that's the better scenario if you can get away with it. Okay, one more question, anybody? One more question? All right, I guess the question is, where's the bar? All right.
All right, let's give Neal a big round of applause.
Thanks for having me.